Carl Skinner is a name synonymous with firefighting and forest management in the United States. He began his career as a firefighter in Lassen County in 1968 and went on to become one of the most respected and accomplished scientists in his field. After an illustrious career spanning 42 years with the U.S. Forest Service, Carl retired in 2014, leaving behind a legacy that continues to inspire those who work in the field of fire science today. Carl Skinner's contributions to the field of fire science are numerous and far-reaching. He is particularly interested in the interplay between fire and climate, and his research in this area has helped to shape our understanding of how wildfires behave and how best to manage them. His work has been instrumental in the development of fire management strategies that are both effective and environmentally sustainable.
Hi, I'm Carl Skinner, and I'm a retired research geographer, retired from the Forest Service, and I was in the research branch and worked out of the Redding Laboratory with the Pacific Southwest Research Station. And I worked for the Forest Service for 42 years, half of that time in fire management and then half of the time in research. And what I'm going to talk about today is this fire history and why it matters. And I love trying to figure out how things came to be the way they are. And so that's one of the reasons that I ended up spending a lot of time in fire history. And I do think it matters because it gives us an idea of where we might be headed in the future. There are various ways of coming up with fire histories. And some of them are looking at charcoal and sediments that collect in lakes and such. There might be layers of charcoal ethnographic accounts, talking with native people and others about how fire was used and over time and such. Tree ring records, we can actually get a lot of information from the trees themselves because they often record the fires that went by and growth anomalies. And then historical records. Historical records are usually the shortest ones of these. And the charcoal records go back the longest in time. And so I'm going to focus mostly on some of the ones that I've worked on the most, but these are various ethnographic accounts. And Tending the Wild, Kat Anderson wrote this about management by native people of California vegetation and such, and it's really interesting. And then she also has a chapter in this book. And she was one of the editors of this one. What's interesting is I love the name of this book, Before the Wilderness. And I asked her, where did you come up with that name? And she says, well, before the Europeans came and called it wilderness, there were people here living here and they were managing it and working just their daily lives. And she says, so it wasn't wilderness then. And so that's where that name comes from. And it's a very interesting book. But these are ethnographic accounts. Historical records are like newspaper accounts. You can run into those. I spent time in the library at college going through old newspapers and stuff and that. And then written fire records. Most places, they're pretty good since the 1950s. Before that, they get sketchy. Just depends on where you are. Mostly, these are since fire suppression. We have very few historical records that go back before fire suppression began. So they don't tell us a lot about how fire used to work. This comes from Hayfork. The forester, Wilson, was the one that examined the area of the Trinity Forest Reserve, which became the Trinity National Forest and then was later combined with the Shasta, into the Shasta Trinity. And he says fires have been ground fires and easily controlled. A trail will sometimes stop them. And this is the Hayfork landscape. And then there's this one, which C. Hart Merriam, who was chief of the Biological Survey of the United States, spent some time in Siskiyou County. And he said this about fires: of the hundreds of persons who visit the Pacific Slope in California every summer to see the mountains, few see more than the immediate foreground and a haze of smoke which even the strongest glass cannot penetrate. That's pristine air. Anyway, so there were a lot of fires in the past. And that's what we're trying to understand, is how did they work? How did they provide the forest that we had? And so this is the amount of fire activity that we have seen since fire suppression in the western US. The 11 western states. And you can see here, early part of the century, of the 1900s, they're somewhere between 1 million to 200, maybe. I mean, 1 million to 2 to 3 million acres in a big year at that time. And then it drops off a bit in the 30s and early 40s, probably from the CCCs, the Civilian Conservation Corps. First place I ever worked for the Forest Service was in an old CCC camp, barracks and stuff, station. And then you see it really drops off, the amount of fire activity in the 1950s and 60s. That was after World War II. We got all kinds of bombers and trucks and dozers and equipment to use. And we got pretty good at putting out fires for a while. But then things have turned up. Starting in the late 1970s, especially in the West, and this just continues right on to today, and increasing amount of fire activity. And this is millions of acres. You see the total here in this big year for the entire Western United States was a little over 8 million acres. That's 2012. Yet, California alone, we used to get probably between 4.5 to 12 million acres a year burning. What happened? Things have changed, and how did that work? This is from Scott Stevens' work. He's at UC Berkeley. So charcoal and sediments as a fire proxy is kind of interesting. And the reason I show this is Grass Lake. Between Weed and Klamath Falls, and it's an interesting one because Kathy Whitlock and her students have cored this lake. It actually goes back before the last ice age into the intervening period between ice ages. That's a couple 100,000 years. And they're still working on it, getting it published because there's so much there. But charcoal gives you thousands of years, normally back to the last glacial period. And this one goes back farther. But it only gives you trends. We don't get annual resolution from these type of data. And the reason for that is that most of the lakes that we've worked with in Northern California are very stable watersheds, and that over time there's not very much stuff coming into them. And so you don't get annual layers like you do in some places. You just get a mush of stuff that collects in the bottom, and it turns out about per centimeter, you get maybe 30 to 50 years worth of time. Which means that for every inch, you're getting maybe 100 years of time or more. And so that's, all you get is trends out of it. But you can get fire and climate relationships in the sense of what kind of vegetation was there and how much charcoal is coming in from it at a time and that kind of thing. And so that's one of the reasons we do this stuff, is just to look at the long-term trends. Tree ring records. This is what I spent most of my time doing. I worked with Kathy and her students and other paleoecologists on that work, but this is mostly what I focused on. And with tree rings, they're temporally accurate. They're accurate to the year and sometimes the season, as long as you cross-date them with known datings of trees and stuff. But it's one point in the landscape, it's a tree. So you need lots of points to be able to understand how fire is moving through the landscape and affecting the landscape. So many points are needed. But these are pre-suppression. These come from the period before we started putting fires out. And most of the cases that we've seen here in Northern California, we get about 300 to 500 years worth of time out of it. We do get trees every now and then that go back 1,000 years. And like some Douglas fir that we found at Hayfork and incense cedars. We've got 1,000-year-old incense cedars that we found too in places, but there's not as many of them. So we usually cut it off somewhere around to 500 years statistically. So these types of fire histories, though, are most valuable in low to moderate intensity fire regimes. They're not very valuable where the forests burn up when the fires go through, because then all you have is a record of when the last fire went through by the new trees that grow up afterwards. Everything else was killed. And so these are most valuable in forests that when the fires go through, they don't kill everything. In fact, a lot of the trees stay alive. And here's kind of what we do. We go out and we search places that have had fires, and especially places that, this is Thompson Creek watershed out of Happy Camp. And this entire watershed burned in 1987. And here we are in 1992, a few years later, after it had been salvage logged and various other things. And this was left alone. And hunting for fire scars to see where we could, what samples we can collect. This is Alan Taylor again. And this is Edie MacGyver. She was worked with the district and it was really good. They allowed her to work with us, and that was very helpful. And so when we find something, then we cut it out of the stumps. And this is Donnie Glenn. He was also from the district. He went on actually to be a fire management officer on another forest later on. And he was really helpful too, and very excited to be able to use the great big chainsaw. And then, and this is Glenn. This is Valerie. She's from the Tree Ring Laboratory in Arizona, professor there. She's done a lot of work with us. We're working. This is in actually in Southern Oregon, out of Cave Junction. And so these are the things that we look for, and we try to see what we can collect, and then you get to carry it out. And this is Celeste. She works at the lab down here. And in some of these studies, we've actually carried tons of this stuff out of these canyons to be able to put together the information. And then we work on it in the laboratories and date the rings. And we come up with this on each individual sample. And then we put many samples together. This comes from Hayfort. This is where this one comes from. And you can see the patterns, over time of how fires work. These are larger fires. There's 3 of them in there, and then these others are here and there and that, and they actually go together with the landscape once you know it. What's interesting is that this one right here, this is 1829. We haven't found a place north of Tahoe into Southern Oregon that doesn't have fire scars in 1829. So this is kind of what we see from this. This is from Black's Mountain. Here's a fire that we detected on different stumps in 1777. When did the next fire come? It was 1780, but it was over here. It didn't burn into this. And then 1781. Oh, now we're going to reburn a little bit of that one. And then 1782, way down here on the corner. And then we have 1783, which ended up burning over the whole thing, which is interesting. So we can put these things together and look at how they correspond with reconstructions of climate from different periods. But the other thing is this, when we look at our samples, we can look in the tree and see where the scars are occurring. And each of these rings is a year's growth. This is, the light colored is the spring wood when the tree's growing rapidly. And so the cells are large and you don't have a lot of cell wall. And the dark wood is when it's slowing down in the later part of the summer, and you get more cell wall wood, and so that becomes darker. And so what you can see is that here, this one is in the ring. It's in this later period, so it's probably a late summer fire. Here, this is springtime. You can see it's in the early wood. And so that must have been a very dry year, is what we have found. Is if we find something that's spring wood like this in California, it's usually we can see that that was one of the drier years, because things dried out rapidly. And then this one is at the ring boundary. So it would have been like September-ish or maybe October. And so here's what that looks like graphically. You can see, and we try to locate data-wise early wood and where in the early wood it is, and late wood and dormant. Now it's interesting when you go to if you were in the Southwest, you interpret these very differently, these locations. Basically, because most of their fires, like I said in an earlier talk on climate, the Southwest has a dry spring. That's their fire season. And so the spring wood is normally when they would show up in the wood. They don't get very many late wood fires. They do get ring boundary fires, but what that means in the Southwest is that's the early spring. It's when things are just opening up. So it's interesting. You have to know where you are as to how to interpret the rings. So if we use these data, we can actually see how in a particular year, fire moved around the landscape. Now this is at Black's Mountain again, because it's a 10,000 acre area, and we actually sampled over 500 trees out there that we have the data for. And so we collected 1841 early. And that's when it shows up right here in this area. And then here's middle early. The fires spread a bit. And then we go to late early, and it's spreading a little bit more. It's kind of interesting, though. It's avoiding all this. We don't have anything there to record. That's because that's a big wet meadow, is the reason for this, surrounded by the forest. And then late wood, it's finally made it around the meadow and into another part of the forest there. And then at the ring boundary, it ends up here. So basically on that 10,000 acre experimental forest, it took this thing all summer to be able to move across the forest. It's very different than what you would expect today from fires to do. And this is places where we have collected. There's more people than us that have worked on. These are the people I've worked with. And Rick Everett, he's up in Montana now, Kerry Metland Nature Conservancy, Scott Stevens at Berkeley, Alan Taylor at Penn State, and Valerie at the Tree Ring Lab. Those are the people I have mostly worked with, but there are other people that have done work here too. And so there's more data than these actually to look at. But the tree ring-based histories mostly cover the period from 1600 to 1900. And this is reconstructions of climate for the last 1,000 years. And those periods, even though those fires are that frequent, happening all the time, was much colder than this period of 1960 to 1990. Kind of interesting to think about. And Black's Mountain in the 1920s, this is the kind of forest those frequent fires gave us. This was before the forest had a lot of opportunity to change. But it did change, and because by the 1990s, that place looked like this. We've actually changed it back to that, but in a big experiment we're doing there. Now this is I think, interesting. We looked at tree ages. We've cored thousands of trees across Blacks Mountain as well to look at when did they start and how well did they grow and how did fires affect their growth, that kind of thing. And so these purplish ones down here, these are our tree ring record that we have that we collected the samples from. And some of them like go clear back here to almost 1100. That was an incense cedar up here. But you can see most of it's in here, but we have a good sampling going back to 1300, 1400. But look at all of this. These are the live trees that are out there, is what the yellow is showing you. And there's another way of looking at that. Let me overlay this with the fires. This period right here is what I'll concentrate on. That goes back 1600 until 2000 or so. And it looks like this. The fires are the green. That's how many of the sites with scars were scarred by multiple trees, not just a single tree, but on multiple trees. And the yellow ones here are the younger trees that have come, that were either initiating back here, growing the live trees, and then this. And what you see is, here's introduction of grazing came in, and they brought sheep herds in here and pretty well wiped out the grasses and so forth. And so all of a sudden the fires cease. And that's the last sizable fire, was right after the grazing came in. And what you see is that all these trees are already started, and now there's no more fires to keep thinning them. And so boom, we get this thing. And then on top of that, we pile in fire suppression in here. But what's interesting is that this drops off. Why do you think it drops off? Because the place is occupied. The ground can't hold any more trees now. It's just full. And they're competing with each other, and they became very dense and such. So we were thinking that if we take all these data that we have, Alan and I and Valerie, we thought if we put it all together in a great big database and try to look at what climate was doing over time, could we pull some interesting stuff out of that? And so what we did was we took this area within that ring and put all of those data together on one great big database and started running it against climate reconstructions that we knew about. And we actually ended up with a mess. It didn't do what we wanted it to do, and we were trying to figure out why it wasn't working. And here's what we ended up with, actually, to look at the amount of fire activity over time. This is the number of recording sites out of that and what was going on. And you can see here's a big different area and such in there, and then almost nothing here in that particular zone. And so what's going on is what, we looked around for some way to analyze this in a different way, and I found where some people were using some statistical methods to look at first sunspot cycles, and then it turned into, I found where they were using it for looking at salmon runs in the Northwest, and how you could pull out temporal periods. And so I tried it on our data to see if we could pull out some periods that would be different. And sure enough, we ended up with 4 distinct statistically different times. Before I go too much farther, this is 1829 again, right there. Well, what this turned into was, and we published it in the National Academy of Science, Proceedings of the National Academy of Sciences. This is the Native American period, Hispanic period, the gold rush, and then fire suppression is basically what came out of it. So then when you look within each of those, you find that there are patterns. But you can't, since they are statistically different from each other because of what humans were doing, it makes it so that we couldn't analyze the whole thing as one great big pile, which was kind of interesting. So we did publish that, but there was a part of it that was very interesting to me, but they said our paper was too long, so we had to cut something out of it. And this is the modern period. I actually enlarged that for you a little bit, and it's kind of what I already showed you with that others, how it started here and then kind of does this thing. It's this. I was looking at drought compared to how much of the area burned. And so what we have here, this is the most area burned, and this would be the driest. This is the Palmer Drought Severity Index, is what the PDSI is. And so you have the driest years here and the wettest at 1. It's just all relative that way. And then this is the biggest area burned and the least, is the way this goes. And what you see is, when it's dry, you get a lot of stuff that burns. And when it's wet, you don't. And well, we didn't need to study it to know that. But the next one is what was really interesting and what we wanted to publish, but they have made us not publish something and shorten the paper. So this is what didn't get in there, these two things. This is Western North American reconstructed temperature. And this is interesting because this is the warmest and the coldest. And then this is area burned, most and least. And what you see is really interesting. It goes just like this towards the warmest, like you would expect it to, and then all of a sudden it stops. Even though it's getting warmer, you get less fire. And that is the fire suppression period, is the warmest period, when you would have expected more fire. But we weren't getting the fire. And so it's really interesting. And so that's why I wanted to show that, because it really shows the effects, I think, of what's happening with what we've done in terms of management and with climate change. So stand structure, species composition, the changes over the 20th century in fire regimes of frequent low intensity fires, we've changed them. And I've already pointed that out. And this is Black's Mountain again. And here also Lassen Park, where Alan Taylor went in and did that work, where they could, the Park Service first set it up so that there was data points at every section corner, so a mile on a side. And they took photographs in the 4 cardinal directions and described the vegetation. And then Alan Taylor got the contract to come back and do it all over again in 1992. And that's the same place taken, and the photograph is in the same direction from the point, because they monumented all the points with metal and so forth. And so this is the kind of forests that were not unusual in the past. This is the Beaver Creek Pinery. It is a wilderness area that, because probably its location and hard to get to for everybody, it kind of keeps burning. And so it had burned just a few years before taking this photo. But an awful lot of what we've done turns into forests that look like this, like at Black's Mountain. And these places burn very differently. This kind of forest tends to burn like this. So the trees survive mostly, except for the smallest ones. And then these kind of forests burn like that, and that's what we see a lot of today. Thank you.